All right. So hello, folks from IndiePy. I've come here today at the invitation of Calvin and his team to tell you a story about debugging. Now, I tell this story because it's a good tale. There's a lot of fun, a lot of excitement, a lot of interesting things, but also I tell it because I found out that I myself end up learning the most about debugging by hearing about the interesting hunts that other people have gone on. I can remember being a beginner and somebody telling me, "Oh, you just put a breakpoint in there and debug." And the question at the top of my mind was always, "What the hell does that mean, debug? I don't know how to do that." So the more stories I heard about people hunting down bugs and the things that they did, the better I got at doing it myself. And I'm hoping that you'll find some lessons in the pain and agony that I went through for this particular bug hunt as well. Now, it's also true that I like to tell this story and I like to hear stories because oftentimes we imagine ourselves to be like this, right? Tough guys, supremely competent, very skilled at their craft. But in reality, the vast majority of us are a hell of a lot more like this guy. We're too clever by half. We kind of stumble around looking for things, and we generally end up finding the solutions to our problems as much by chance as through our own skill. Now, there's a couple of specific lessons that I'm hoping we're going to learn as we work our way through the talk today. The first one is that even for the experienced, print can be a very useful debugging tool. The second lesson is that logging can be exceptionally powerful, whether you're working inside or outside of Python, and it can be especially powerful when you're working in both places at the same time. From the standard library, the inspect module is a really useful tool for helping give you context to your bug. Finding out the environment and the stack that you're working inside can help you make sort of parallel leaps or sideways leaps from one chunk of code to another. Another thing that you learn as a result of gaining context is where problems occur don't necessarily always correlate with the location in which you end up seeing a problem. It's also important when you're debugging that you learn to trust your instincts. If you've gone too far down a blind alley or into a place that seems especially dark and spooky and you want to back out, it's usually the case that you probably should, because it's unlikely that the code is going to end up being there. So trust your instincts when you're debugging. And finally, the real lesson of this entire thing is that reading the manual is in fact a valid debugging technique and may even be the kind of thing you want to do before you start. With all of that out of the way, though, let's go ahead and get started with this particular tale. My story, of course, as the title would suggest, is about using Pytest to test a Django application. And the first question that might come to your head is, hey, Chris, Django has this built-in test runner. Why would you do this at all? Now, this isn't really the place or the time for me to go into super detail about this, but suffice it to say that our team really enjoys using Pytest, and so we do. And if you also like Pytest, you should know that there's a plugin that does a great job of supporting Django testing. It's called Pytest Django. And if you're going to follow this path and test Django using Pytest, you should absolutely use this add-on. With it, testing Django in Pytest is simple and easy, except, of course, when it's not. This traceback popped up when I was working on a particular feature for our application. Let's see, if we look down at the bottom here, you can see that there's a connection that's hanging open. And if you look up at the top of the stack trace, you see a frame that tells us that we're in the middle of a bunch of code that's about tearing down databases. So right away, we know that at the time that we're supposed to be removing databases after a test run is completed, for some reason, there is a connection that's still hanging open, and it prevents us from removing the database that we've created for the purposes of testing. Now, before I go any further, I want to talk for just a moment about this line in the traceback. It results from a change that Django made in their exception wrapper class. They use this class to alias all the various errors that are raised by all the different databases they support into a single set of Django exceptions. And when you're writing a framework like Django, it's a good idea to do things like this because integrators who are using your framework only need to care about the exceptions that your framework raises, rather than worrying about exceptions that are coming out of packages underneath, like PsychoPG2 or something like that. But the downside, of course, to aliasing exceptions is that they can mask the original. Django updated their wrapper code to go from this, raise DJ accept value with traceback, to this, raise DJ accept value with traceback from exe value. The general pattern that they're following is this: raise one exception from some other exception. This is an example of what's called exception chaining. It allows us not only to see the traceback from the aliased error, but also the original exception that was raised. And this allows us to get much deeper into the context for our issue than would be the case if all that we could see was the alias. Now, don't get me wrong, exception chaining's been with us for a while. It's not new code. I only mention it here because although it is something that's been around for a while, I still meet a lot of folks in the Python community who aren't really aware of it and get confused by this exception was raised by the following exception or was the direct cause of the following exception. All right, enough of that. Let's get back to my story. The worst part about this error was that it only happened some of the time. These types of bugs are often the worst to find because there's a bit of randomness involved. Now, I'm a believer that there is strength in numbers, although there are those folks who would rephrase that as misery loves company. So I went looking for travelers who'd stumbled at this point, and I found them. There were a couple reported bugs. One of them was even in Pytest Django. But the thing was that all of them had to do with threading or multiprocessing, and I didn't have threading or multiprocessing involved in our setup at that time. So I didn't have a heck of a lot of confidence that these reports were going to be relevant to my particular issue. I did also find a number of blog posts about Postgres that recommended a brute force approach to this issue. I even found one bug report in Pytest Django that suggested adding a fixture to simply terminate any dangling connections that were left over at the end of a test run. Now, this seems to me to be kind of a hammer, and I'm not really a believer in using a hammer where a pair of tweezers will do, but there was a piece of useful information in here. The name of a table in Postgres that tracks open connections and queries that are going on inside the database while it's running. If I use that table, I could at least find out what query was associated with the connection that was left open at the end of my run. I just needed to be able to see this from somewhere inside running Python code. That gave me an idea. If I print the rows in that table right where the database is about to be destroyed, I might be able to find out what queries are still ongoing when it happens. In order to do this, I needed to find a good place in the code from which to print. Now, there's a couple of criteria that I consider important when I'm looking for a good place to add print statements. The location needs to be something that's going to be called every single time my problem happens. I don't want my problem to happen and not see log output. I also want to reduce the noise of my output, so the location where I'm looking should not be called too many times when my problem isn't happening. Finally, I want to find a place where the information that I need is already in scope, or the tools, or the pieces and parts that I want to work with. Or I need to be able to easily fetch them from the context where this print statement is happening. When I looked at my traceback, this is the line that jumped out at me. First, the location here is likely to be called whenever my problem arises, as the function that's being called here is called destroy test DB and is a part of the process of tearing down the test database. Since my problem always happens when the database is being destroyed, this frame is likely to be hit pretty much every time. I apologize. Hang on just a second. I need to deny that call. There we go. The other reason that this is good, or the second reason that this is a good location, is because below this line, the names of the methods indicate that the code is going to become too general. See how all the functions down here are called things like execute. Those functions are going to be used by any database query code, and that means that it's going to be called billions of times and be way, way, way too noisy for me. I'll never be able to see the needle that I'm searching for. But why not use the line directly above it, this destroy test DB that doesn't have an initial underscore? Well, to understand why I made this choice, you need to understand that the authors of Django tend to follow a particular pattern through their code base. They pair up methods, they tend to pair up methods into a public wrapper without an initial underscore that does setup for an action that's about to happen, and then a private actor where the action itself takes place. You'll find this pattern all over Django's codes. Method without an initial underscore, and then a second method that does have the initial underscore where the actual action is going on. If I'm going to interact with the DB, my code should go in the same place where that sort of interaction is happening, because it's going to give me access to that database because that access is already established. I'll have the right tools I want and all the context I need right there. All right. When I opened this file in my editor, I found out that I did indeed have access to a thing called a connection and to something called a cursor. Well, what's a cursor? Turns out that way back when, the Python team established a standard API for any package that wants to interact with a database. It's called DB API 2. Of course, the 2 is just because it's the second version of the specification. And the vast majority of packages provided in Python that give you access to a database will use this same API. If you know about this API, then you can be comfortable using any kind of database package, jumping into it and playing around with it, because the APIs provided by that package will always be at least mostly the same. Individual packages may have methods that are specific to the implementations of one database or another, but in general, the same set of API methods are going to show up there. I learned this when I needed to teach a Python class about databases. You can learn it by using the same source that I did. Doug Hellman writes a wonderful blog called the Python Module of the Week about reference implementations of various modules. And he has one called SQLite 3 about this reference implementation of DB API 2. It's a terrific reference and really, really helps you to understand the internals of that particular library and how it works. All right, let me see here. Remember, at this point, my theory is that there's a query that's still running when tests are finished, and that this query is preventing my database from being torn down. So I have a goal here. What I want to learn is what queries are open at the time that I'm going to drop the database. What I decided to do then was to select all the roles in that special PG table and print them out using the DB API 2 cursor methods execute and fetch all. When I ran my tests after adding this little print line, the good runs printed out like this, an empty list indicating that there were no open transactions or queries going on. Runs that failed, however, contained a single row with the query rollback inside them. This is good news. I can see evidence for my problem. I'm gathering pieces. But rollback is a pretty generic query. It gets used to undo the work done in a single transaction, and transactions are really common things when you're working with test code. We use them to manage the queries that create database tables and to delete those tables after they're done. It's used to insert fixture data and then to remove that data afterwards. And it's also used to isolate the changes to data that are made by individual tests from each other. So which of those situations is this particular situation? Honestly, I'm going to have to keep digging. My new goal is going to be to find out what query is happening in the transaction that isn't being rolled back completely. To do this, I need to look at the Postgres logs because the query itself is already completed and is no longer in my table when I choose to print. To log what's happening in Postgres, I have to modify a database config file, and that meant that I have to find it. I've done this a million times, but I can never, ever remember where the stupid config file lives. Luckily, Postgres provides a really nice, simple command that you can use either at the command line or from inside a database connection in order to find out the file location of that config file. Once I'd opened that file in an editor, I added these lines to the logging section. The first two enable logging and tell me where the files should be stored. The next three tell what a type of events within the database we're going to log. We're going to log all statements that get created, all connections, and all disconnections. The next line says how to log how long each event takes. I'm not sure that I need that, but it could be useful in establishing a chronological timeline, just in case log lines are ending up being out of order. The final line is a prefix that's going to get prepended to each log line with a bit of extra information. Notice that I've also chosen to add a new line and a tab after this prefix. I like to do that because what it means is that each line, the log line and then the traceback underneath, is going to have a pattern to it. That pattern is going to be easy for me to see when I'm looking at it in a terminal, and it's going to make it much easier for me to parse the information that I'm looking at. Now, as for the prefix, there's a lot of extra bits of information that I could see. I chose these 4 pieces of information because at the time they seemed like the most likely to help me answer my questions. I could just as easily have picked different ones, but these ones seemed like they were going to be useful to me. Having done all of that, in preparation for my test runs, I opened up a terminal and I used the tail utility with the -f flag to follow these Postgres logs that were getting printed out. Doing this means that every time a new line gets logged into the Postgres log file, it will immediately show up in your terminal and you'll see all the new lines right as they are happening. This is super, super useful when you're trying to catch things in real time. Having done this, there was much rejoicing. I went to look at successful test runs. And let's take a look at what happens here. There's a connection numbered 70 that creates the database and then a little bit later is closed. Then there's a connection numbered 71 that's used for database setup and for all the tests that execute. Finally, connection number 72 destroys the database, and we can see a rollback query that happens just before that. That's pretty hopeful looking. I think I might have found something here. When we look at failed test runs, though, a different pattern emerges. Here, you can see number 43 creates the database and then closes shortly thereafter. Number 44 is used for the database test setup. We can also see number 44 close, and 46 opens to drop the database. But wait, 46 is not contiguous with 44. If you remember before, all of the numbers for connections were in a sequence. Here, we've got a missing number. It's in connection 45, right? This rollback shows up in connection 45. And at the end, it's that same connection, number 45, that's left open. Well, why? Why is there an extra connection there? This is what I had to find out. In the middle of the logs, I found the first statement for connection number 45. And right before it, there was a query statement about migrations. In my fever-addled brain, this seemed like a clue, something that I could follow to try to find where in the code this extra connection was going to get set up. But I really need to understand what's happening inside my code at this point. I want to dive into it so I can map what happens there to the things that I'm seeing happening in these logs. That way, I can find out what's the source of this extra connection that's getting opened. At this point, I know a couple of things for absolute certain. I know that there's an open connection that is preventing our database from being destroyed. I also know that the dangling request has a rollback transaction going on inside it. I also know that the opening connection is created during database setup and that the extra connection is opened before the tests are run. And finally, I know that the extra connection is related at least temporally to the migration process. Now, before we continue, remember that we're using Pytest, and there's a little bit here about how fixtures work that you need to understand in order for the next part to make sense. Check out what's happening here. We have a test called test foo exists that asserts that the result of calling the find a foo function is that there is, in fact, some truthy thing that gets returned. To this test, we add a fixture that we're going to call create a foo, and its job is to create a new one of these foo things so that that thing can be found. Notice how we pass the name of that function as an argument to the test function, test foo exists. This is how fixtures work in Pytest. It allows us to create shared pieces of code that multiple tests are going to need and allows us to sort of abstract away some of that common stuff that you don't necessarily want to look at while you're testing. Pytest Django provides a DB fixture. This thing controls access to the database, and without using it, a test can't actually access the database at all, and an error is thrown if it tries to. This is honestly a really, really useful little feature because it helps you to find database calls that are buried underneath the code that you're writing that you may not even know exist. The database figure depends on three other fixtures. Requests is a global fixture that gets provided by Pytest. It allows you to carry context from one fixture to another or from the fixtures into the tests. It's a useful little global thing. The Django DB blocker fixture controls the blocking of access to the database, turning it on and off. But this function in the middle, the fixture Django DB setup, sounds like it's related to creating and setting up a database. Migrations, I know, happen when we're setting up the database. So let's take a look in there, see if we can find anything. If we zoom into this Django DB setup code, we see that it imports and then calls a little bit of Django code that's actually used to set up the databases. That's good. Django already does this. There's no need for Pytest to create its own code to accomplish this task. If they use Django's implementation, it means that their code is more easily forward compatible to future versions of Django. So we now know that the DB fixture ends up calling through this Django DB setup into Django's own setup databases code in order to get that database created. Let's move over to that file and dig around a little bit. Looking at the function, we can see that it calls something that's named createTestDB. I'm willing to bet, based on the name, that this has something to do with a createDB query. So let's take a look in there and see if we can establish a code narrative that matches what my log lines are showing me. Yep, There's a place where it writes a query to create the database, and immediately after this, it closes a connection. This matches really well with the logs for connection number 43 that we saw at the beginning of our failed test run. Right after that, we can see that a Django management command is called, the migrate command. This has to do, of course, with something that might make a query like the one I saw in my logs. And right after this, that odd connection number 45 is open. So maybe in this code, there's something new that opens up a new connection for us. If I look just a little bit down from there, I can find something called ensure connection that gets called. Sounds like something that might be used to make sure a connection exists. If there are situations where a connection doesn't exist, that could explain why this problem I'm having happens sometimes and not others. I'm willing to take a step back and rejoice here. It seems like we've made some good progress. So let's go over and take a look at that ensure connection function. My theory, of course, is that sometimes this function creates a new connection and sometimes it doesn't. In other words, that if statement is occasionally true and occasionally false. In order to prove that, I need to add a print statement inside this simple function. If I'm right, then this text that I've added in here will only show up when test runs fail. If a test run succeeds, it will not show up. So, print statement added, I decided to run my tests, and bam, there it is. The silly connection message shows up. And then I see it again, and again, and again, and again. Failed, succeeded, it's always there. And it happens so much that I can't tell whether or not it's related to my problem. I am, as the saying goes, very disappointed. This was the only thread I had to work with. If this method is called all the time in failed and successful runs, well, maybe there's a situation going on somewhere further down the stack. Something in how I got to this code that changes from one run to the next. I need to get a little bit more visibility into the path that leads to my current location. So I'm going to use the inspect module from the standard library. This module is wonderful. It allows you to look at all sorts of internals for your code that's running. For me, the important part is seeing a call stack. Now, you all know what the call stack is, even if you've never heard the term before. You've seen it when you see a printed traceback whenever an error happens. Each function that calls puts a frame on the stack. Call a new function, add a frame to the stack. Call a new function, add a frame to the stack. And this goes on and on and on. Inspect provides this useful method called currentframe that gives you access to a tuple of information about the frame that's at the top of the stack. There's 6 pieces of information that you get. There's the frame object itself that represents the current running function. There is the name of the file in which that particular line of code is. There's a line number for where that line is found inside the file. There's the name of the function that is being called at the moment. And there's a list of lines of context and the index of the current line in that list of context. It's pretty useful information. If we use that method to grab the current frame here, it's going to represent that call to ensure connection that we're sitting inside. There's a second stack-related method called getOuterFrames that provides you with a list of all the frames that are in the stack below the current one, starting with the one that you pass as an argument. To find out the function that called this one, we can grab the next element of that list and print its name. Remember that the name of the function was the third element in the tuple of information about the frame. All right. After I added this print statement, I noticed that successful runs look like this. But failed runs were different. There was an extra function that was called getAutoCommit that showed up in the middle of that stack. Maybe there's something in that function that is conditional. Let's go look at the code. Unfortunately, when we look at the source, it appears that that is absolutely not the case. Every single time getAutoCommit is called, we're going to call ensure connection. So this can't be the location where the change happens. I'm going to end up having to look further down the stack in order to find what I'm looking for. Now, this time, what I'm going to do is print all of the frames that come back from getOuterFrames. This way, I don't end up adding another one and then adding another one and adding another one, coming back and re-editing the file a million times. Having done that, I received this stack trace, which I like to call the stack of doom. And there is the call to getAutoCommit. Right one frame down below that, the function that calls getAutoCommit is an enter method. Now, if you know something about Python's data model, this enter method is a special method that gets used to create context managers. Context managers are the power behind with statements. So anywhere you see a with statement, an enter function is going to be called. Looking at the source, I can see that inside get autocommit, it's called if the connection is not in an atomic block, but it's not called if it is. So what is an atomic block? Well, an atomic block is, yeah, you know what, screw it. Never mind. This code is super deep in Django's internals. Autocommit, transaction management, all of these kinds of things are core to the functioning of databases. If I'm looking here, then I am definitely in the wrong place. In fact, I always say, if you're looking in transaction management, don't. Just walk away. You'll be happier if you do. Going back to that stack, we move one level up to this enter method, or from the enter method into enter atomics. This is the call that has that with statement in it. Maybe there's a clue in there. If I go look at the enter atomics method, I notice that it dealt with iterating across database names. And this was the point where it started to occur to me that I actually had more than one database. I use replication in my setup. So there's a master or a primary database and a replica database. Could the fact that I have those two things be part of the issue? Well, let's print the DB name that gets used here and find out. I'm expecting at this point to see different names here, but instead, when I run the code, every single time it's the default database. Once again, I am very disappointed. But then this is where things went a little bit sideways. Sometimes when you're in the midst of a bug hunt, an intuitive leap happens. Lightning strikes and you get an idea. Now, intuition is kind of a crappy word for this. It depends a lot on your having familiarity with the code that you're working in. The better you know the code that you're working in, the more likely things like this are to happen. I remembered seeing DB name somewhere else, way back at the very beginning of the hunt, back in that setup databases function. Open the code and there it is. The code at this point is iterating over a dictionary of database signatures that are pointing to database names and aliases. Maybe there's something going on in here. Oh, whoops, hang on a second, let me go back. Just after that line, the code iterates over aliases to the database, so maybe there's something there. I'm gonna look at those aliases and print them out, and when I do that, successful runs look like this. But when the runs fail, we got this instead. This is the point where I suddenly knew what was going on. And maybe you're also there at the finish line, but I'm going to walk through the rest of this just to make sure that we all get there at the same time. The test databases symbol, as I said before, is bound to a dictionary of information about databases. The keys in that dictionary are database signatures, and Django uses the connection settings from our databases for those pieces of information. Remember that Django uses a dict to contain database settings. When it creates a signature for each entry in this dict, if it has the same parameters, then it's going to have the same exact signature. At the same time, in order to ensure that only one database is created, when we iterate through all of these aliases, we only make a connection for the very first alias. Now, what's important to note here is that at the time that this bug happened, we were using Python 3.4, and we were on an earlier version of Django that is current. And in Python 3.4, there was something that was different about dictionaries than what is different the way they are now. Nowadays, dictionaries have ordering. It's an implementation detail, but it's a stable ordering when you run Python. At that time, dictionaries were unordered constructs. And what ended up happening was that every time we created the database, we used whatever alias was first listed in the list of database connections in our Django settings. But when we run the tests, every single time you run the test, it always uses the single alias for the default DB. Honestly, this can't be as stupid as I feel like it is right now. If it had been the case that this was really true and that the ordering of your database aliases mattered and would cause problems like this, there'd be howls of pain across the universe. Everybody would be screaming and shouting and yelling because extra connections would be popping up all over the world. So I went looking for documentation. And of course, there it was. Right inside Pytest Django's documentation, it says, hey, if you're using multiple databases, you might want to check out this information over here because we don't really support that particularly well. In Django's docs was the other half of the information. If you have replica and primary databases, then you should be using this little setting right here in your replica database to let Django know that this database is just a mirror of the other one that you have. And so the solution to my problem was this. 3 lines. After 3 days of hunting this stupid bug, 3 lines. And really, it could have been 1 line, honestly. I only broke it out into this form so I'd feel a little bit less guilty about the amount of time it took me to find it. Now, I believe in leaving the world a better place. And so what I did was realize that my problem was looking at this original documentation for Pytest Django. I glossed over the multiple DB thing because I was thinking about multiple DBs as representing a database that corresponds to a certain set of models in your Django app versus a separate database that corresponds to a separate set of models. That's another form of multi-database use that's a little bit more common, and one that I was using as well. I didn't realize that it meant also primary replica setups. And so I opened a pull request in order to help highlight the fact that primary replica setups are also a form of multiple database operations. Luckily, the folks who are running Pytest Django, and in particular Blue-Eyed, merged my PR, and so that documentation has been updated. Hopefully this is going to ensure that nobody else will end up in the same swamp that I had just fought my way out of. So that's the end of the bug hunt. We've reached the end of the story, but there are some lessons that I ended up learning. During it, I learned that print is especially useful. Really, if you're looking for things that happen a lot and you want to hunt for differences in them, using a print statement to print out a whole bunch of different things and mowing over them with your eyes to find changes is a super helpful way to handle the problem. Logging is also a very, very powerful tool, especially when it comes to correlating the goings-on across different systems, like when you're using a test framework and a web framework and a database all together. You can use logs to find places and parts that correlate with each other. Getting context is going to be super important and helpful. And when you get context, you may end up finding out that where you want to be may be a very different place from where you currently are. I also learned that it's really important for you to trust your instincts when you're on a debugging hunt. If you end up down inside code that you don't feel like you ought to be in, you're probably right, and your problem is most likely somewhere else. And the final lesson that I learned, and of course this was for the umpteenth time, is that one must always, always, always read the manual. I'd like to thank you all for your time today. I know it was a fairly quick talk, but I hope you enjoyed it. I'd also like to thank the folks at IndiePie, Calvin and Mary Beth, who reached out and gave me the chance to come and talk to you today. And finally, I'd like to offer thanks to my employer, Coffee Meets Bagel, who of course pay my salary and allow me to come and give talks and things like this during events that are happening right in the middle of my workday. I really enjoyed myself, and I hope that you did as well. I'd be remiss, of course, if I didn't mention that we're hiring. So if you happen to be the kind of person looking for a job and you're interested in helping people make connections and go out on dates and get a chance at love, or if you just have questions or comments about the story, you can hit me up on Twitter, you can email me, or I guess there's going to be a nice question and answer session here right after I'm done. So I'd love to talk to you. And yeah, that's the end. Hope you all enjoy.
That is awesome, Chris. Thank you so much. I loved that story. I love diving deep on a problem like that. And I hope that this was therapy to help you feel better about yourself and what happened there. Because I know as a developer, I have been there multiple times.
Oh, yeah.
So thank you so much.
When the
Please,
amount of effort to fix is absolutely not commensurate with the amount of effort to find.
believe me, if more folks who are kind of coming into being a developer could understand that or kind of feel that, I think it helps them feel better about themselves too. So that's awesome. Please feel free to turn on your video or turn on your microphone, ask questions to Chris. He has seen, obviously, as you just saw, all kinds of crazy problems and has debugged his way through them. I love the way he describes it. I was finally got my answer on Twitter. You said we're going on a bug hunt, and I'm like, man, there's a song we used to sing in camp. what was it? Oh, we're going on a bear hunt. We're going to catch a big one. And
That's right.
so I think next time we get around a campfire, we're going to have to sing that song with you so we can also, celebrate this moment.
Sounds good. I'm looking forward to it.
All right, who's got questions? Step right up.
So I've got a question.
All
Have
right,
you
Theo.
ever, yeah, I'll just launch in. Have you ever found yourself going back into the Git commit history of certain open source projects to get any clues that way, or direction, inspiration,
Yes.
using the blame essentially?
Yeah. I mean, Git blame is super useful. What I find it especially useful for, particularly if you're looking at a repo where the commit messages are good, Git blame can be a really, really excellent way of gaining context into why something was done a particular way. And I find that kind of context can be really helpful when debugging, right? If I look at something and I'm like, God, that's an idiotic way to do that, which of course happens all the time, especially when I'm looking at my own code, good commit messages from earlier in that repo's history can often tell me that there was something that they were considering that I was not considering. For example, in this particular one, I gave this talk to a group of students, and one of the students was like, well, the easiest way to solve this is just to change that database settings thing from a dictionary into a list. Then they'll always be ordered and you won't have to worry about it. And I said, well, yeah, that's true. But there's a whole bunch of people out there in the world that are counting on this being the way that it is. And the Django people did it for a reason. They wanted to have the keys for each one of those database settings and to be able to use that key reference in order to look things up later. And without that context, you could easily be fooled into thinking that the right thing to do would be just to change the dictionary into a list. But knowing that context can be really helpful, and Git blame is a great way of gaining it.
And open source projects that maintain great change logs are also super helpful.
Absolutely.
Because you may notice that it worked in a previous version, doesn't work in a new version. You can now scan, a dozen or 24 lines of changelog and be like, oh, that sounds familiar. Go look at that commit.
Yeah, it makes a huge difference.
Exactly.
Oh,
All right,
I have
Piero,
a,
what else?
I have a
Go
couple
ahead.
questions.
Hi, PW.
Hi, how you doing? This is a great program. Thank you, and the check's in the mail. Let's see. Oh yeah. Chess. How did you hear about the Heisenberg principle?
I come out of a sort of eclectic background. I was not originally a computer science guy. I started out my life as a jazz trumpet player, and went from that into music performance, and then into music composition, and then into experimental music. And somewhere in my sort of late 30s, I began programming computers in order to do algorithmic composition. So I came to programming pretty late in life. But one of the things that I did when I was a musician and an artist, especially in my experimental music phase, was I read a lot of extra material. So I think the first place that I ever ran into this was the Tao of Pooh, which I had picked up to read about sort of philosophical connections. No, not the Tao of Pooh, it was the Tao of Physics, Fritjof Capra, which is a wonderful book about sort of the relationship between Taoist principles and the physical world. And the Heisenberg uncertainty principle was in there.
Okay, I've got a few more questions. I think it's pronounced Tao, but that's okay. Let's see, along with the Heisenberg principle, how do we get a hold of you?
So my name is Cris Ewing. It's spelled there in the middle of my window right there. Twitter is @Cris Ewing, which is nice and easy. And you can also reach me via email, either at chris@coffeemeetsbagel.com if you happen to remember that I work there, or chris@chrisewing.com.
Okay. And then can this be applied to penetration testing, pen testing, or not?
I would make a statement about that, but I am really not a security guy. I'm one of these very trusting type people. And so I'm not a good person to answer that question.
Oh, okay. Well, I don't trust anybody, so I understand. The last two questions, Chess. What's the lockdown like, and what's the weather like?
So we're in Seattle here. The weather today is warmer than it's been for the last few days. So we're in the sort of low 60s. It's sunny and beautiful outside. Lockdown's been an enormous pain in the ass. But we are done with it at this point. My wife and I are both vaccinated, and my children got their second dose of vaccine just on Saturday. So both of my children are on their way to being immune. So we're really looking forward to being able to step outside again.
So you've been
That's
jabbed.
awesome. Yep. Thanks, PW, for bringing a human element to the question and answer. I like
Well,
that.
thank you.
Who else got questions? I have a quick comment. Like when you first started off and you're like talking about debugging and how you're gonna like go into like a PDB or a debug session, I had that exact same experience. And it was on a project, and I was actually working with Kapil, and he was like, well, let's drop into a debugger. I'm like, what are you talking about? And so he was the one who introduced me to PDB for real.
Yeah.
And I was like, and my life changed thereafter.
Yeah. Yeah. But that first time, I swear, like
Yeah.
the person who introduced it to me said, oh, just import PDB and then type pdb.setTrace with a little set of parens and then debug. What the hell does that mean? Debug is such a, like, it's a really vague word. How to start, what to look at. There's a million different things you could do. Which thing are you going to do? That
Right.
was the thing that it took me a really, really long time to get any good at.
But that's
Or
a
in
big eye
Clone when
opener
you're
for beginners.
learning, when you
Yes.
have the postmortem debugger that pops up and you at first you just learn, okay, hit C,
Yeah.
just hit C.
Exactly.
I did that for years before I actually learned how to use it.
Oh my God, there's something
Well,
useful there.
Right. And in fact, the fact it doesn't tell you right away that you need to like go up one stack before you get something interesting.
Yeah.
It's like you've ended up in the stack where that thing got called.
Yeah. Yeah.
So it's not so much a question as an observation that Chris did the extra nice thing, which is to go into the documentation and propose an improvement, to it, which is wonderful. Because it's not just that you solved your problem, but you tried to smooth the path for people who come after. That's wonderful.
I figure that, you know, if I can make the campsite a little cleaner than it was when I found it, it's going to be a good thing. And, you know, I did in fact read the manual, and I had read through that paragraph, and it just slipped right past my attention as I was reading it. I didn't go any further. And
So what you did is you looked around the campsite and you picked up all the poo.
Yeah, exactly.
So I have one more. When you started talking about chaining exceptions, like
Yeah.
that's not a new thing. I mean, obviously it was new to Python when they added it as like an official PEP.
Yeah.
But who remembers from the Zope days of failed to render the standard error message?
I don't know that I ever saw that.
Oh, I'm sure you did.
Yeah.
It's like an exception would get caught, and then it would get, like the exception would cause an exception in rendering the standard error message. So you get an
Right.
exception actually about rendering the standard error message, which masks your original exception.
Yeah. Super helpful.
It's super
The kind
helpful.
of thing that keeps your blood pressure nice and low and even. Yeah.
Ain't that the truth? All right. Any other questions for Chris? I mean, he's battle tested. He's seen all the things.
I do have one compliment I want to toss out there. I think this presentation is like the high score for me actually understanding all of the GIFs that were interspersed in there. I think I scored myself like 98% of them I got.
Oh, I'm really glad.
It's great. Nice touch.
Well done.
I can't believe how relaxed Chris is. Look at him. He's just lying back, is like
just sitting here chilling.
Jeez.
Yeah. Well, what else are you gonna do when you give a presentation? This is gonna be. I'm gonna take his cues from this presentation and do this my new style.
And
I was telling Calvin before all this started, this is not meant to be disrespectful to you folks. I'm having a bit of sciatica problems, and sitting up does not feel particularly good for me right now. So I'm laying down because that way I don't have to groan in between every other sentence.
I just thought you were showing off.
You win the award for best delivered in a prone position.
And this is such a relaxed presentation too, and compared to some of Chris's talks from before, I think he probably had like 3 slides per second. So I remember when he was giving talks, he would prep like 200 slides and he'd go through them in about 15 minutes.
I think there's 160 in this one.
Oh, okay. So you cut back.
Yeah.
Definitely cut down.
Just a little bit. I like fast moving pictures. I hope the code samples came across cleanly. That's sort of the challenge, is to get those to show and not to be too fast through them.
That was great.
That was really good. Any other questions for Chris? Don't be bashful.
I liked it a lot. So going back to the original statement, just debug the problem. So when I explain this to one of my developers, can you debug that for me? What's a better thing for me to say? Like show them your presentation or give them things to do?
I think, so I taught a Python boot camp for a couple of years. One of these things where people come in, they want to switch careers. And we worked specifically on using the debugger in that class. And for me, I think the best way to help somebody new understand the process of debugging is to sit down with them and work with them through their first problem. And to do so by asking questions. Things like, well, what symbols do we have? What pieces of information are available in this frame? What have we got access to? One of my early debugging tools was this wonderful thing in Clone back in the day. They had this little JavaScript disaster thing that you could use to open up a shell, an interactive Python interpreter right in your web page. And it would allow you to interact with all the objects that were there. And of course, it was not like read only or anything like that. So you could totally destroy your website with the thing. But it was a wonderful way of like getting into a piece of code and looking at the various symbols that were present and printing them out and talking about what they meant and what pieces of information they represented. It can be a little bit demanding to do this the first time through with people, but I think doing so really helps. And yeah, talking to them about developing a narrative about what they are trying to find out, right? To me, the important part about debugging is the first question you need to ask yourself is, what did I expect to have happen? And what actually happened? And what's the difference between those two things, right? It's that difference in there between what happened and what you expected that is going to be the place where your problem lives. And if at every step, when you find out something new, you re-ask yourself that same question, what do I know now? What did I expect? And what actually happened? You'll continually end up finding ways to generate a path on to the next question.
Oh, Chris, I have a question and then I got to go. So,
okay.
Calvin, could you just email me my door prize? The question is, what are the 10 commandments for debugging?
Are there 10 commandments?
Well, I was hoping
I'm sure there's probably 10 tips, but that sounds like a great presentation for the next Indie Pie.
Actually,
PW, maybe you should give it.
Yeah, I like that. I'm unaware of, I have not myself come up with 10 solid rules for it. My basic rule is that one, right? What happened? Yeah. What did you expect? What's the difference between those two things?
But I think sharpening your tools around that kind of game, like, evolving from just PDB, like does your IDE give you a better debugger experience?
Mm-hmm.
Have you looked at PUDB, which is an amazing like alternative to just the regular Python debugger? It gives you more kind of a curses-based graphical thing.
Yeah.
I believe I'm a tools guy, but I think if you hone your practice and like kind of sharpen your power tools that you've got sitting at your own desktop, that's going to help you, like, I don't know, see them much more clear. Like, especially like, I'm a PyCharm person too. And man, the PyCharm debugger is really fantastic to be able to just browse through the stack and browse through all the variables and stepping all the way through and in all that. It's way easier with a graphical debugger than I think than a PDB experience.
Yeah.
You can do it. It's just you have to be a real wizard and a pro at it. And I'm not debugging every day, but when I am, I really want to be efficient and effective at it.
Yeah. I suggest that for a future meeting sometime.
Yeah, I love that idea.
Cool. Okay, gotta go. Take care. Great meeting. Great meeting.
See you, PW.
Yep.
Farewell.
Now if he wins door prize, he's not eligible. He must be present to win.
Oh wait, I'm back. I got time.
Oh, he's still here. Oh, he didn't leave. All right. Any other questions? If not, feel free. Like we got plenty of time. Ask away. Chris is available.
Yep. My kids aren't even in the house.
Wow, look at you. We got Chris for the whole afternoon now.
At least until 2:30 when they come home from school.
Yeah, there we go. So any questions for Chris? Yeah, I think debugging can look daunting at first.
It absolutely does. It's terrifying.
you feel like you're gonna be digging into like memory addresses and spaces and things like that. It's not that. It really is. It is approachable, but someone's got to show you first, I think.
Yeah.
So since we're talking, you've brought up the topic of IDEs. Chris, do you use an IDE? Which
I
one?
do. Yeah. I'm a PyCharm guy now. I used to be very much a text editor and shell dude.
Me too.
But then I worked at a job that had an enormous code base, and like building the what is it, the C tags for it to try to be able to
Yeah.
change the symbol took forever, and it pissed me off so much that I decided I needed to switch to an IDE. And I really haven't looked back since. I've found it to be really useful. But I think the important part is to have a tool that you are comfortable with, right?
Yeah.
Whatever your comfort level is, whether it be an IDE or a shell and a text editor, or Emacs or something like that, as long as you're productive in the tool and you feel like you understand how to use it well, it's the right tool.
Watch out, Chris. You said the Emacs word. That's
Yeah.
gonna set Kim. That's gonna set Kim off.
Hey, you made my day. You made my day.
I have a coworker who is a dyed in the wool Emacs guy. So I have to give respect.
It's going to be very old wool.
That's true.
He is the
Yeah,
only person at the company who's older than me. So yeah.
Yeah, I can't emphasize that enough. I feel like during the coding boot camps, because I've been involved in a coding boot camp as well, and it's really hard to kind of cover the fundamentals of coding and like the language you're learning and sharpening your skills at like whatever IDE or set of tools you're going to use.
Yeah.
But that's kind of on you as your journey as a developer. Like
Yeah.
really, that's your moneymaker. That's how you are becoming a better developer, is through setting up your dot files in crazy ways and making these efficiencies that like really like make you a better developer.
Yeah. Yeah.
At least you appear as a better developer.
There's a lesson I picked up somewhere quite a few years ago, which was if you just spend 15 minutes a day, or let's say even 15 minutes a week, just reading the documentation on your editor or your IDE, just to find what kind of tools are in there that you never suspected were in there. And just, if you spend 15 minutes, you're going to find something new.
Yeah. The important part for me is finding a way to use those things. I remember
the muscle memory is hard to grow.
I remember at some point, Eric Steele, who was another member of the Clone community, is the release manager still for the Clone content management system. He told me that he had made it a goal of his to learn a new method from the itertools module in Python standard library, like every week. And during the week that he was working on a particular method, he would find as many places to use that method as he could, so that he used it a whole bunch of times. And that would help him to sort of establish the muscle memory of what that tool was useful for, and where to pull it out, and what time to apply it, and so on. And I think it's a reasonable approach, right? Find something new, find some new piece of information, and then use it again and again and again, as many times as you can, until it's sort of locked in your head, and then you can, just continue.
That's kind of difficult though, for like from the perspective of the bootcamp student though. They are under a lot of pressure to, get through a huge amount of stuff.
Oh yeah.
In my experience, like doing debugger things with students it's difficult to carve out some time for that, but the payoffs, like you said, are enormous.
Absolutely. Absolutely. I think, the learning how to use a tool like this is indispensable. And sure, you're going to spend an hour more than you might have spent otherwise because you chose to use the debugger instead of doing, what was comfortable to you. But it's definitely a tool that will help you down the road. And so I tried very hard to help my students learn how to use it.
Back in the early days at Kenzie, when class sizes were not, more than 50 people in a cohort, we were able to do that like on a one-on-one basis. And a lot of the students there needed, they needed to be shown like how to use the debugger to get that initial comfort level, so they could go off and explore it on their own.
Absolutely. I think what's useful is to have sort of a set of minimal functionality that you ought to know in order to proceed. Mm-hmm. And then once you've got that minimal functionality, you can kind of let them go and they can explore the rest of it. But as long as continue and list and where and that, I think that's probably about it as far as like the very basics of PDB go, right? Get out of the debugger, show where I am right now, show me the stuff around me. That's a nice basic set of tools.
How do you jump over a for loop?
Me, my general, and this may not be the most efficient way, but my general approach is to set a breakpoint at the first code line after the for loop.
Yeah, there's built-in support for it now in PDB though to jump out of the current loop you're in, I think.
I've heard that. I haven't had a chance to use it yet. Unfortunately,
either.
in the last couple of years, I've moved out into the world of management, and the amount of time I spend writing code anymore
Yeah.
is
Yeah,
minimal.
and I'll be on PyCharm, and PyCharm has built-in like stuff for that too. So
Yeah,
totally get that.
Philip Bauer gave a really good training at the Python Web Conference this year.
Oh yeah, that's awesome. I'll have to go look up the video.
I don't think many about those videos live yet. Or is that like next week?
June 18th at 8 a.m. They will all be live. Yes.
Sweet.
I'll send it to you, Chris.
Thanks. I appreciate it. Any other questions or thoughts?
I have a
hesitate.
question.
Go for it, James.
First, my name is James. I'm currently sitting right outside London in a small town called Luton.
Oh, awesome.
Yeah. I wanted to ask, do you think you would have written any test to compensate for that bug which you found?
Like tests to demonstrate that the fix had worked?
No, that would have actually discovered that the database name was not in order.
Oh man, I don't know. I mean, the funny thing is that it actually works the way it's supposed to work. I honestly
the mirror
don't
around.
know. I think any test that covers this would have to be in Django itself, right? And
Right.
the conditions that lead to the test happening are esoteric enough that it feels to me like it's not necessarily a thing that Django was going to test for. It would be interesting to go and look and see whether or not they had such a test. But given the fact that they use this default database alias as the way to connect to a database during tests, and that they use the first alias when they run the tests, like oh God, what is his name? One of the core contributors to Django, the guy who wrote South the first time, was sitting in the audience when I gave this talk at North Bay Python.
Andrew.
And he had written this code, and yeah, Andrew, exactly. He'd actually written this code, and as I was heading into that file, he was, sitting over in the corner covering his eyes like he was afraid
Like, oh, no.
that I was going to find some bug that was down inside that stuff. But when I talked to him about it afterwards, he said, I had a reason for doing it that way. This whole like using keys to look things up was the most efficient way to handle the problem of dealing with multiple connections in a system. And so I actually don't think the behavior that's there is bad behavior, James. I think it's correct behavior. It was me not reading the manual and understanding that was the behavior that led to the bug in the first place.
Okay, fair enough. My
And
second question,
James, I've been to your little town.
have you?
Yeah,
Recently or a long time ago?
about 3 years ago.
Wow, I wasn't even here then. I just came about 2 years.
Do you have a follow-on question?
Yes. In the best practice while logging, is
Mhm.
it better to log at like the middleware level, or do you log way down towards the function level?
I think a lot of that depends on what it is that you're trying to find out.
Mm-hmm.
So I work in a lot of production systems, and people tend to put log lines right where something is happening. And oftentimes in like production code, an exception will get raised around a log line, or they'll log an exception and then allow the exception to get raised. And it'll end up being caught at the top level by something else. Or maybe it'll end up getting caught multiple times as it bounces its way up the chain to final exit. And so occasionally you'll end up with situations where you'll have like 5 log lines showing up in Kibana, all of which just result from the same one error. And it makes it look like there's, much worse things going on. To me, like in production, a log line that is close to the actual code is going to be more useful to me if what I'm looking for is evidence for a bug hunt. Like if I'm trying to find a problem, having log lines that are close to it is good. If on the other hand, what I'm trying to do is to gather sort of global information about a system, having that information happen higher up the stack is usually more helpful.
Okay, okay, cool. My last question is, how do you debug like environments? For example, if you need to debug your production environment, maybe I can give a very quick example. I had once a bug that oriented from too many open files. But how I had done it was every time I did not get the response that I wanted, I gave an exception that it just says the file cannot be created. So in my logs, I was seeing file cannot be created, but I had to drill down to understand there were too many open connections.
Like what the actual reason for that error is.
Yes, exactly.
Yeah.
So what's the best way to debug that specific issue? Because if I run that test on my local machine, it seems to work pretty well because
it's not
the
a
number
production.
of open connections was never reached the maximum number.
Yeah. There's a whole class of problems like this where a bug that shows up in your code can only really be seen when whatever application it is under production load, right? The difference between running something locally and making 2 connections to it and tossing it up into a production environment where there's 50,000 connections a minute or something is huge. It's a tremendous difference. It can be very, very challenging to debug those kinds of things. Obviously, it's not going to be easy for you, and you probably shouldn't be necessarily shelling into some production machine and running a Django process in there just loose. And equally clearly, you can't put a breakpoint into code that might get hit by clients. A couple of approaches that I have seen used or that I've used myself are to set up a kind of a canary. Right now we use Kubernetes, so it's possible potentially to set up a pod that isn't necessarily hooked up to production, but is running in the same environment as production, so that you are sharing the same set of resources that all of the other production pods are sharing, but you're in your own sort of isolated environment. That's one approach that you can use. Another approach that I'll do, which is obviously a lot slower, is to wrap a particular bad thing or the spot where a bad thing is happening with a bunch of information log lines, and then doing a quick release to production of those log lines, and then tailing logs and looking for the information that those new log lines that I added are going to produce. At that point, you're really sort of using print debugging rather than like a debugger. But if you're pretty sure where something is going wrong, it can be a very useful way to approach that problem.
Yeah, another way I'd recommend is something like Sentry, where when that error happens, the whole stack gets reported over to Sentry, and you can actually browse up and down the stack in a post-mortem style.
It'll show you what symbols were in each frame and what their
exactly. So it's kind of like the debugger, but you get it after the fact, and you can do it on production pretty safely.
Yeah, I have yet to be in an environment where Sentry wasn't around when we.
It's super nice.
It's a very, very good tool. Yeah.
Okay, cool. Thank you.
Yeah, because we've had the same problem where you can only observe a thing under load, and it's just impossible to generate the right load to make it happen.
Yeah.
Okay, I'm debugging one of those right now.
I was looking at you and Caleb as he was talking about that, like, oh, this
I know.
is happening this week.
And unfortunately, Sentry's not on that environment. It will be very soon.
There you go. So the third option is to install Sentry. Install
Sentry, yes. And profit.
There you go.